Hello everyone, and today we are going to discuss a very interesting topic. But before we start, I have one question. You all know either we are using our mobile or we are charging our mobile. So I just want to know the energy conversion. Like you already know, suppose there is a fan here, right? And in the fan, you already know the conversion is electrical energy is getting converted to mechanical energy. So what can be the energy conversions happening in this mobile when we are using the mobile and when we are charging the mobile, right? So yes, you all are correct. When you are charging the mobile, the conversion is electrical energy to chemical energy, and when you are using the mobile, the conversion takes place like this. It's chemical energy to electrical energy. So basically today we are going to discuss this. Okay, we'll discuss a branch of science that studies preferably this part of the energy, right? So it is known as electrochemistry, right? So what is electrochemistry? It's a branch of chemistry that deals with the interconversion of chemical energy and electrical energy, and it's really a very dynamic field, and it's the field of future, because you all know that we have coals, we have fossil fuel, we have oils, we have natural gases. They are all going to deplete in the near future. Like we will have coal for the 200 years, for 60 or 50 years we'll have the petrol. If within 20 years these natural gases will vanish, so obviously there is a demand of an alternative source of energy. Okay, so we already know solar panel, solar energy, and wind energy, geothermal energy, they are also there. But yes, this is really very dynamic field, and it's the field of future, that is the electrochemistry, where you are trying to get energy from the chemicals, right? So basically it's a redox reaction which is taking place in these type of reactions. So before we proceed ahead with electrochemistry, we must know the basics of a redox reaction. So when we say oxidation, you should have at least four things in your mind. Oxidation means addition of oxygen, loss of hydrogen, loss of electron, and increase in the oxidation number, right? So these are the four things you need to remember, and automatically when you remember this point of oxidation, then the reduction point forms automatically. Like if addition of oxygen takes place in oxidation, so removal of oxygen takes place in the reduction. Addition of hydrogen in the reduction, so removal of hydrogen in the oxidation. Apart from this, loss of electron, gain of electrons, just have this in your mind. And please have one thing in your mind, that not only gain of oxygen is oxidation, it can be gain of any electronegative element also, like the halogens. Okay, and similarly, not only loss of hydrogen, it can be loss of any electropositive element like metals, right? So this is also one way to determine whether a particular reaction is redox reaction or not. And why the word this redox is come? Why can't we say oxidation and reduction reaction? Or why can't we just say oxidation? Why can't we just say reduction? Okay, so this question comes in our mind. So the answer for that is redox reaction combines reduction and oxidation because they take simultaneously, right? So if anyone is losing electron, okay, if any element is losing electron, if any ion is losing electron, then definitely someone will be gaining that electron. Okay, so this is a simultaneous process. Okay, like I will lose electron only when someone is ready to accept it. So oxidation and reduction, they are going to happen simultaneously. So please keep it clear in your mind, and the best way to learn that is with an example. So here I have one example here, right? So if you see, I have sodium metal here, okay, and the chlorine as the non-metal here. Now you already know here, since sodium is a metal, definitely it would like to lose electron and it will undergo oxidation, okay? And chlorine is a non-metal, would like to gain electrons, so it's undergoing reduction. So sodium is undergoing oxidation here and chlorine is undergoing reduction here. And please remember that if any substance is getting oxidized, it is known as a reducing agent, and if any substance is getting reduced, it's known as the oxidizing agent. Okay, Now, why is it like this? Okay, first let us try to identify. You see here the oxidation state of sodium is 0 and oxidation state of chlorine is 0 because they are in their elemental form, right? They are in their elemental form, right? So now if you see, the oxidation state of sodium increased from 0 to 1. So it's increasing the oxidation state, so oxidation. Apart from this, you can also see that sodium has got one electronegative element added, which is also the condition for oxidation. Similarly, chlorine, if you see, it is going from 0 to -1. That means there is the reduction in the oxidation number, and here it was increase in the oxidation number, the charges increase. And also you see in chlorine, since the addition of electropositive element has taken place, that means this is the case of reduction. So by 3 points we come to know that the chlorine is getting reduced. First, by seeing the decrease in the oxidation number. Okay. Second, by seeing the addition of electropositive element, right? So these are the ways by which we get to know, right? And third, the next thing is that chlorine is also gaining electrons. Okay. So these are the three things which help us in determining that chlorine has undergone reduction. Now see, just because, why we call a substance getting oxidized as the reducing agent? What is the reason behind that? So the main reason behind that is sodium, just because sodium lost one electron, only then chlorine could get one electron. We cannot imagine chlorine accepting one electron if sodium is not ready to give it. So sodium has helped chlorine to get reduced. So that's why sodium is a reducing agent. Similarly, chlorine is an oxidizing agent. Okay. And remember one thing, apart from calling reducing agent, you can also call them as reductant, and oxidizing agent can also be called as oxidant. Okay. And this is how we represent it in the form of equation, that sodium loss of one electron. So we represent it like this. Okay. Obviously one question might be coming that it is losing electrons, so how plus is coming in sodium? So actually it should be like this: sodium is losing one electron, okay, but we shift this one electron to the right hand side, and that is how you get the equation. Whereas the equation of reduction is quite clear: chlorine is gaining one electron and getting converted to Cl minus 1. Okay, so that's about the basics of a redox reaction. Right now let's learn about the types of cells, okay, which is important with respect to electrochemistry. Right, so basically cells are of two types. I showed you two examples. Okay, on one side we were using mobile, and on the other side we were charging the mobile. Right, so these are the two different processes happening. Right, so when you're using the mobile, the battery of the mobile acts as the electrochemical cell. You all know our batteries, which are the storage capacity, have the storage capacity, they store energy in the form of chemical energy. Okay, they are nothing but the lithium ion batteries. Right, so electrochemical cell, basically what they do, they produce electricity. They are also known as galvanic cell. Okay, because Dr. Galvani gave birth to electrochemistry. Before that, no one had clue that chemical energy can also be harnessed to get electricity. Okay, and Alessandro Volta, he developed the first battery in the world which could produce electricity from the chemical energy. So it is also synonymous with electrochemical cell. So you can call it electrochemical cell, you can call it galvanic cell, you can call it voltaic cell. And the example of electrochemical cell is the Daniell cell. Right, we will learn about this. Okay, so please remember these points. And you know, as and when you connect battery to a system, the energy depletion starts then and there itself. You just cannot stop it. This process is spontaneous. Okay, so the conversion of chemical energy to electrical energy is a spontaneous process. Okay, so please remember this as well. Okay, it's not going to happen on its own. Like even if you don't use your mobile, you just leave it like that, definitely if you will open it after a few days, you will find the battery getting depleted or battery getting over. Okay, so definitely there was the conversion happening in the background. Okay, the conversion of chemical energy to electrical energy was happening in the background. Right, now we have got this electrolytic cell. So as the word says, electro means electricity, lytic means breakdown. So we supply external electricity and we basically make we restore the chemical energy. Right, so this is what happens during charging. So electrical energy is getting converted to chemical energy, and this doesn't happen on its own. So it's a non-spontaneous process. Okay, now let's learn about the Daniell cell, which is an electrochemical cell, and it is also known as zinc copper cell. So let's see the laboratory setup, and he is the scientist John Daniell, basically responsible for the development of this cell, right? So that is also very important. So if you look at the setup here, we have two metals. We have zinc metal, okay, zinc metal as the anode, and we have copper metal as the cathode. And please remember, in the in the reactivity series, we have learned that zinc is more reactive than copper. Okay, and also have one thing in your mind, that more reactive a metal, okay, so the more reactive metal will get oxidized and the less reactive metal will get reduced. So here zinc will be getting oxidized, okay, that means it will be acting as the reducing agent, okay, and copper, it will be getting reduced, okay, so it will act as an oxidizing agent. Okay, so now we have taken these two metals in two separate containers containing their respective solutions, which is also known as electrolyte. So zinc is the electrode, and zinc sulfate is the electrolyte. Similarly, copper is the electrode and copper sulfate is the electrolyte, right? And there is a bridge here, okay, which is basically to maintain the continuity of the circuit and maintain neutrality also. We'll come to know why, okay, and how the functioning is happening of this, right? So we will discuss this further, right? Let's understand the setup. We have a galvanometer also to detect the presence of current, okay. So let's try to understand the functioning of electrochemical cell in a better manner with this animation. So you see, I have got it converted into an animation, right? Now, I hope the setup is clear to you and you have understood one thing, that zinc is more reactive than copper. Okay, zinc is more reactive than copper. So it will undergo oxidation and reduction will be carried out by the copper, right? So let's listen. Now you see, this is the setup. I have decided this setup very properly, right? Now you see here zinc electrode is there, it will get oxidized. So obviously it will get oxidized, then it will lose electron. So you see these two electrons. Okay, so who has lost these two electrons? Zinc has lost these two electrons. So how we'll write it? Zinc has lost two electrons. So we will write zinc has lost two electrons like this. Okay, as I told you in the previous slide, this is how we write the oxidation reaction. Okay, now zinc has lost electron. Definitely someone has to gain it now, because it's a redox process. So these two things have to take simultaneously. Okay, so copper ion present here, okay, the copper ion present here will gain that electron. Now how are we going to write that? Copper ion will gain the two electrons, okay, and it will get reduced, right? So see, this thing has happened. Now copper will approach here, okay, copper will approach here, these two electrons will be approached, and ultimately what will happen? Copper will get reduced. Okay, so let's see this reaction once more. Zinc, this side, this side oxidation is happening, and this side reduction is happening. Basically the left side oxidation and right side reduction. Okay, so just remember this, right? Now again electrons will be lost, and electrons lost from zinc has been gained by the copper, and we can write it and just see the experimental result. You see the zinc is getting corroded, zinc electrode is losing its electrode, and copper, the deposition is happening on the surface of copper. So obviously zinc will become, okay, this will become thin, okay, and this copper, it will become thick, because deposition is happening. Whenever there is reduction, there will be deposition taking place, right? So obviously now we can summarize it like this. Oxidation happened at the left side, okay, and the right side reduction happened, reduction of copper, oxidation of zinc, okay. And if you cancel the electrons from both the sides, so we get this equation. This is known as the net ionic equation. This is the net ionic equation which is being shown here, right? Now we already know zinc, you see zinc, the oxidation state is 0, and here you see +2 and copper is 0. So you see Zinc is basically here, what is happening to the zinc? Zinc is getting oxidized because increase in the oxidation number has taken place by 2 electrons, right? And if you see copper here, okay, so copper has got reduction in the oxidation state, okay, decrease in the oxidation number, okay. So we have seen the decrease in the oxidation number by 2 electrons, right? And zinc becomes our reducing agent, okay, because it is losing electron, it is getting oxidized. And copper, this copper plus 2 ion, it becomes our oxidizing agent because it is getting reduced, okay. Now there is a method of representation of this type of cell which is known as cell notation, okay. And look at this type of representation, okay. This basically sometimes, many times it has come for 1 marks in Cbse, so it has to be taken very seriously, right? So zinc here represents the electrode, and zinc sulfate solution contains zinc ion, okay. So this is the electrolyte, so this is the electrode, electrolyte, okay, and this is the gap between them, okay. Now this is the double gap, this double gap represents the salt bridge, okay, it represents the salt bridge, okay. So please remember, with respect to this Daniel cell, we have to remember the lone concept, okay. LOAN, okay. Why the lone concept? L for left, okay, L for left, okay, O for oxidation, A for anode, you see oxidation has taken place on anode, and N for the negative terminal, okay, N for the negative, because you know electrons are traveling from, okay, zinc, okay, it is traveling from zinc to copper, so obviously electrons travel from negative terminal to the positive terminal, right? So this become your anode, becomes negative terminal, and cathode becomes the positive terminal, okay. It totally depends upon the movement of electron, and obviously the movement of current, okay, the movement of current will be opposite to the direction of electron here, right? So this is what we understand, right? And it has to be remembered very properly. So like that, you see there are various example of cell notations, okay. So please take care of this cell notations also very properly.